All right, just to kind of pick back up where we left off, we finished the last two problems on the front, just some. Okay, just making sure. All right. So, just one of the big things is remember, anytime you're doing a stoichiometry problem, what is a must? Balanced equation. Now, just take about 30 seconds and see if you can balance this one. You should be yelling something at me. It's already balanced. Very good. So 1, 1, 1, 1. Great news. Okay, great news for us. So question is, how many grams of fluorine? So what is it asking me specifically about? Which is, what formula? F2. So I want to know how many grams of fluorine are required to produce 290.8 grams of cobalt-2 fluoride. What compound is cobalt-2 fluoride? COF2. So you're telling me I have 290.8 grams of that stuff. I should just kind of reiterate a few things from yesterday. First of all, what unit are we going from and to? Grams to grams. What compounds are we going from and to? Cobalt-2 fluoride to fluorine. Same or different? Different. The only way to compare two different compounds is by using what? Mole to mole. Well, what's the problem with the unit that I'm given? I'm given grams, so I've got to go to moles first. Let's start there. So I've got 290.8 grams of COF2, and I know I need to get rid of it. So if grams of COF2 is on top, where's it go? On the bottom. So I've got grams of COF2, and I'm going to moles of COF2. Okay? Can I stop here? Got to keep going. I'm not quite sure where I'm going yet, but I know that moles of COF2 has to go on the bottom. Well, at some point, I've got to get from cobalt-2 fluoride to fluorine. At what point do I get to that? This step right here. This is called my what step? My mole-to-mole step. So I'm going from moles of cobalt-2 fluoride to moles of F2. So far, unit-wise, our grams canceled, our moles canceled. Can I stop there? Now, I could, if the question was what? How many moles of F2? I could stop, but I can't because I need to go one more step. And so I need moles of F2 on bottom and grams of F2 on top. Now notice, again, one, the units cancel, leaving you with what you want. And number two, I have no numbers plugged into this thing at all. Numbers are arbitrary. Numbers are always going to change depending upon what you're working with, which reaction you're working with. Now let's start in the middle just because it's the easiest. Where do I get my mole-to-mole ratios come from? I'm telling you right now, somebody's going to mess this up. In this problem, they're going to get lucky. Why? All the coefficients are 1. But you've got to remember that if it's mole and mole, you've got to look at the coefficients. Just so happens they're going to get lucky in this problem, and it's going to work out quite nicely. Okay? Now, grams of F2. 1F is 19, so 19 times 2 is 38.0, and I'm actually going to need some help on this one. If you ever got a calculator, it'd be nice to kind of do this one. I'm sorry, I don't have a periodic table. Do you get periodic tables for me? Yeah, grab the box of calculators. It's on the bottom. What is it? Okay, we'll go with that. So 96.93 is your mass of cobalt-2 fluoride. Now again, how would we do that? We've got 1 cobalt and we've got 2 fluorine. So multiply 19 times 2, which is 38. And then 38 plus the mass of cobalt, which is 58.93. And, yep, that's right. Okay? So, when you run this through your calculator, I want everybody to just run through this and make sure they're going to get the right answer, just so you're making sure you're doing the calculator part right. When you give an answer, there's always 3 things that you must have. What's the 3 things you have? The sig figs, the unit, and the formula. Okay, make sure you have all 3 of those things. Now I'm going to write it down here. What was, you got it, Bradley? 114.0. Okay, all right, so 114.0 grams of F2. 114.0 grams of SOF2. Any questions there? Y'all good? Okay. All right. Okay. No, that's fine. All right. While you're writing this down, Logan, I'm gonna go ahead and get it ready. This bottom one, first and foremost, what type is number 10? What does it look like? I'm hearing both. It is double. Why, I guess my question was, why is it not an acid base? Because there's not a base. Very good. So balance this for me real quick. See what you can come up with. It should be a really, don't say it out loud. It should be a super, super easy one to balance. Logan, you good? So I can go ahead. All right. So what's it balanced? Very good. 1, 1, 2, 1. All right, so the question is, what is the mass of strontium chloride? What compound is strontium chloride? The first one, SrCl2. So now the key here is, notice what they use. They use what word? Mass. Well, what's the unit for mass? Grams. So don't let that throw you off, okay? So what is the mass of strontium chloride that reacts with, notice how they use the words right here, that reacts with. As soon as you see that, what does that tell you about what you're fixing to see? It's on the same side. It's a reactant, right? Well, they ask you a question about one reactant, and they say reacts with. So what does that automatically make the other part they're fixing to give you? The other reactant, right? And then they tell you 300.0 grams of sulfuric acid. So if you didn't know what sulfuric acid was, you can look up there and you can figure it out based on the other words, right? So let's go from there. So I've got 300.0 grams of H2SO4. Okay? What unit are we going from and to? Gram to gram. Okay? So I know that I've got to get 3 in here. So I've got grams of H2SO4. And what do I have to go to first? Because can I go from grams to gram in one step? Nope, sure can't. That's going to mess me up. I've got to get it to moles first. Mind y'all's way, or can y'all see? Okay. Maya, you with us? Okay. I'll go ahead and do all these because I know I'm going to need them. Alright, and so moles of H2SO4 is on top, and so I know I don't need it, so let's just go ahead and get rid of it. So at some point, again, I keep saying this, I've got to get from sulfuric acid to strontium chloride. How do I go from one compound to the other? Moles. So you've got to notice that once you have moles of one, you can go right into the other of that one. I know I don't want moles of SrCl2, so I'm going to go ahead and get rid of it, and I'm going to go to grams of SrCl2. Okay? Alright, I'm going to pause the video, and I'm going to let you guys plug in all the numbers and run all the calculations. So I've got you set up. Now you run the numbers. Yes, sir. Yes, you have, once if you see grams, you have to use the periodic table. All right, so the easy part is the mole to mole. Again, where does the mole to mole come from? Coefficients. Now, what's the good news about the coefficients in this one? It's a 1 to 1. I know that mole and gram, mole gets a 1. Now, what is the mass of sulfuric acid? 98.08. And then what's the mass of strontium chloride? 158.52. Okay. Now, so your answer, again, I've said this enough. You have to have 3 things: sig fig, unit, and formula. So what is your answer to how many sig figs? 4 sig figs. What's the answer to 4 sig figs? 484 point what? 9 grams of SrCl2. And that's our final answer. So, if I handed you 300 grams of sulfuric acid, to make it react completely, which means basically, if I have 8 hamburger patties, I need what? How many buns? I need 8 buns, right? So if I've got 300 grams of sulfuric acid, to make as much product as I can make, what else? How much strontium chloride do I need? 484.9. So that's how I want you to think about this. In terms, go ahead. What mass was different? Okay. What was that? You're fine. You're fine. Okay. Any questions? All right, there's one problem left, right? Well, it's, yeah, kind of, yeah. Yes, sir. All right, well, I'm glad you mentioned that because that's what we're probably going to get into. Probably not today, just because of time. I don't really know yet. We'll see. Um, so, what you were talking about yesterday, we talked about the limiting reactant. So, what is the mass of strontium chloride that reacts with 300 grams? What that means is, if I'm cooking 300 hamburger patties, how many hamburger buns do I need? 300. But in chemistry, it's not an equal amount, right? Okay. Like if I'm cooking a cake, if I have 10 eggs, do I need 10 pounds of salt? Or do I need 10 spoonfuls of oil? You know what I'm saying? It's not an equal amount. In chemistry, it works a little different. So if I've got 300 grams of sulfuric acid, to make it work perfect, to make my cake exactly how I need it to be done, I need 484.9 grams of strontium chloride for there to be nothing left over. I haven't wasted anything. When we get into other things, the limiting reactant, that means I'm going to have some stuff left over, some extra stuff. So the limiting part is what's going to run out first. And so I don't have any of it left. In this case, there's neither one. We don't have a limiting nor an excess because they're perfectly matched. Remember, their numbers don't have to be the same because you can't compare grams. Does that make sense? We'll talk about that tomorrow. Okay? All right, here's what I'm going to do. I want you to do the last, like the balance equation 13 and 14, all on your own from the beginning to end and see what you come up with. I'm going to give you all just a few minutes to do that. All right, guys, if y'all come back up here with eyes. So it says solid, siren. Say this again. I was going to say solid iron, and it came out as siren. Solid iron 3 oxide. So I know I've got Fe 3 plus O2 minus. So I've got Fe2O3 reacts with hydrogen gas. So that's H2 to form iron and water. So Fe plus H2O. Now here's something that's interesting. Here's what I want you to look at. I want you to look at the reverse reaction. Now, what do I mean by the reverse reaction? Products going back to the reactants. Does that look like something to you, the reverse reaction? Looks like oxidation. What is oxidation called? That is the reverse process of rust right there. Okay. The actual reaction that it's referred to. Because when you take iron and you start mixing it with water, what happened to it? It rusts. So really, Fe2O3 is rust, and it's going to give off hydrogen gas. And so this is the rust compound, and they're actually reverse processing that. Don't ask me if you could do that in real life, because I don't think you can, but it doesn't matter. This is just a reaction I gave you. So how many grams of iron are produced? So first of all, it's referring to iron, and it says are produced. So what does that tell you about iron? It's a product, right? So the question is, how many grams of this stuff when 450 grams of iron 3 oxide are reacted? So we have 450 grams. Now, some of you are thinking, whoa, hang on, what's missing so far? I forgot to balance it. So I've got 2 irons, 1 iron, 3 oxygens, no oxygens, 2 hydrogens, 2 hydrogens. So what do I need to do? Okay, so I need 3 here, that gave me 6, and I need a 3 there. Yeah. I was wondering, Callie, let's point it again. It's not 4. I didn't think there was a 4. I didn't think that. Alright, So I've got 450 grams of iron 3 oxide, and then I'm going from what unit to what unit? Grams to grams. So we already have figured it out that I need grams of Fe2O3, and if I'm in grams, can I go right into grams? What do I got to get to first? Moles. So I need moles of Fe2O3, and then I don't want that, so I need to cancel it. So moles of Fe2O3. At some point, I've got to go from one compound to the next. Which point does that occur? Right here, mole to mole. So I got moles of, what am I going to? Fe. Okay, and then I don't want that, so one more step, some moles of Fe to grams of Fe, and so I know that iron is what, 55.85 or 58.55. Okay, I always get those two numbers dyslexically backwards. And then that's 1, and what's my mole to mole? Okay, so here and here, it's a 2 over a 1, and then what's the mass of iron 3 oxide? 159 point what? 68. I need 2 decimal places. Yes, ma'am. Yeah, because it'll reduce. You would have mathematically gotten the answer right, but your stoichiometry would have been wrong. You would have lost 1 point for the middle part, but you would have gotten the answer right. Okay. Now, how many sig figs are in your given? There are 3. No, wrong. There are 2 in your given because the decimal point is absent. My apologies. So there's 2. So what's the answer to 2 sig figs? 310. 310 grams of Fe. So, if I take 450 grams of rust and I mix it with an unlimited amount of hydrogen gas, I'm going to get 310 grams of iron. Yes, ma'am. What do you mean by little off? You didn't go to 2 sig figs. Yeah, I mean, I'll give you plus or minus 1. Does that make sense? Okay. All right. Last one. How many grams of water, so I'm going to change it over, I'm going to do this green color. How many grams of water, so I want to know about this thing, will be produced when 0.0155 moles of hydrogen gas, so 0.015, try that again, 55 moles of that, and this is where some of you got thrown off. React completely with iron 3 oxide. Well, they mention the other reactant, but do they give you any data about it? But if they don't give you any data, then you can't use it. So just ignore it. That's just something there to try to trip you up. So don't let it trip you up. So we're going to start with 0.0155 moles of H2. Now, if I don't want moles of H2, where do I put it? On the bottom. Now, so this is where some of you kind of got tripped up. And this happens every year. People want to go from moles on bottom to grams on top. You can only do that if you're staying within the same compound. But people want to go from moles to grams, grams to moles, moles to moles. They just want to work this all out real funny. If I'm trying to get from hydrogen to water, at some point, I got to flip it. When do I go from hydrogen to water? Mole to mole. Well, if I'm already in moles of hydrogen, what can I do? Go right into moles of water. This is the easy one. Don't mess these up. Okay? So I can do that right there. And then what is my mole to mole ratio? Okay? It is 3 over 3. Now what's the good news about the calculator part of this? It's real easy. You can skip right over it, okay? Just the calculator. It's not the show. And so we're going to move on because they don't want moles of water. What do they want? They want grams. So moles of H2O to grams of H2O. And we know that what's the mass of water? 18.02. Okay? And so it's 0.0155 times 18.02. How many sig figs? 3. What is it in 3? 0.2 what? Grams of H2. There's our final answer. Okay? Any questions on that? Everybody good there? when you look at this one, if you notice something that looks kind of weird, that little box, every time we see a box, this is just a little computer glitch. What's it going to represent? It's the arrow. So just pretend that that box is an arrow. Again, it's just a computer glitch. So I'm going to work about 2 or 3 of these for you, and then I'm going to give you some time to work on their own. So number 1, what's a must of all stoichiometry problems? Balanced equation. Balance that first one. It's really easy peasy. Don't say it out loud. Give everybody a chance to do it. Did you not listen to what I just said? Dadgum, sometimes y'all are like... Goldfish have more memory than y'all. Sheesh. Y'all have a 0 retention span. It's like y'all have concrete in your ears. Alright, how do I balance it? Very good. So, how many moles of PbO, so this is easy, how many moles of PbO are required to act with 2 moles of NaNO3? Now, do you agree that sometimes labeling these things, like under the problem, helps you see where you're going and where you're coming from kind of deal? Because essentially in this problem, I need nothing of that. In this problem only. I mean, I could give you another one that you have to do with it, but we don't need anything. So, the good news about this one is it's really simple. What unit am I going from and to? How many steps? Mole to mole. It's mole to mole. It's going from moles to 1 step. So 2.0 moles of NaNO3. I don't want that, so let's put it on the bottom. Moles of NaNO3. And can I go from moles of something to moles of something else? Yes. And where am I going to get those numbers? Coefficients. What is my top to bottom ratio? All right. Yes, my bad. 1 to 2. And this is even easier. What's 2 divided by 2? Try that again. Is it just 1? Golly. All right, everybody, from now on, something divided by something is 0. Wow. It's not even 0. It's 0.0. You should be sorry. All right, balance number 2. Shh, you're talking too much. What? I'm not talking to you. I could eat a cow, yes. That's a lot of steak and beef. All right, so 6, 1, 2, 3. So the question is, how many moles of iron 3 iodide? Now, we don't have any formulas this time, so we got to think. What is iron 3 iodide up there? FeI3. So my question is, how many moles of this stuff will be produced if 12 moles of silver iodide is consumed? What's silver iodide? AgI. So we've got 12.0 moles of this stuff. Now, what unit are we going from and to? Mole to mole. That's easy. Don't mess that up. So 12.0 moles of AgI. We got moles of AgI on bottom. And we can go right in to moles of Fi3. Where do your numbers come from? Coefficients. Do not grab your calculator on this one. See if you can do it on your own. Please let everybody have a chance to do this on their own. Are you positive this time because you had to use your calculator? All right, what's 12 times 2? 24. What's 24 divided by 6? 4. Now, it's not just 4. 4 point what? 0. Very good. Moles of Fei3. Got to go with that. Don't mess up the mole-to-mole problems, right? Go ahead, Mackenzie. All right. Now, I'm going to be honest, this next one is kind of hard to balance. I'm going to balance it for you. Don't double the hydrocarbon in this one. The reason why is because anytime you have this little oxygen at the end, it makes it really complicated if you double it. So what we're going to do, I'm just going to leave it as is. So I've got 2 carbons, I've got 1 carbon, so I need a 2. I've got 4 hydrogens, I've only got 2 hydrogens, so I need a 2. And then so here's where it gets tricky. How many total oxygens do I have? I've got 4 plus 2 is... Did I do something wrong? All right, I don't think that's going to work out right. No, that is right. That's okay. No, this is right. Hold on, because I need 6. If I put a 2 right there, 2 times 2 is what? Plus 2 is 6. So I'm good. So it's 1, 2, 2, 2. That's a tough one. Yeah, but you got to reduce it. It's just more challenge. Talk to me tomorrow. Okay. All right. How many grams of carbon dioxide? So there's our question. So how many grams of the stuff will be produced if 7 moles of oxygen are used? All right, so I've got 7 moles, 7, just exactly 7, right? Guys, I don't like 1 sig fig. Just for clarification, just change it to 7.0. Let's get 2 sig figs in there. So 7.0 moles of O2. Now, what am I going unit-wise from and to? Moles to grams. Well, this time, I've got moles of O2 on bottom, but I've got to get to CO2. At what point do I convert from one to the other? If I've got moles, go ahead and convert. So I've got moles of CO2, but why can't I stop there? I got to get to grams. Very good. So I've got moles of CO2 on bottom, and I need grams of CO2 on top. What is your mole-to-mole ratio? 2 to 2 is the good news about the calculator. It goes away. Does anybody know the mass of carbon dioxide? Very good, 44.01. So in your calculator, what's the only thing you have to do? Multiply 44.01 times 7, and that's it. What? Oh, okay. I'm glad you said that. Say that one more time. 308.07. Now, I need 2 sig figs. If I'm going to give you $31 or $310, which one would you take? You want 310, right? Why 310 and not 31? You got to have that placeholder, right? Anything beyond the one's place value, keep your zeros. Yes, sir. Yeah, you can't reduce those coefficients. They cancel mathematically, but you don't reduce them. You see what I'm saying? You can plug them in the calculator and you'll get the right answer. But if you multiply 2 and then divide by 2, it's the exact same answer. You see what I'm saying? You still have to include it in your calculator, but you still have to show them. Exactly. If it was 2 over 6, yeah. Okay. That I guess that answers your question. All right, that's the last problem I'm going to do. We're going to give you guys a chance to finish this up on your own.